Welcome to This Explainer. Today, we're going to take a collective deep breath, step right past the immense hype surrounding AI coding agents, and take a really calm, professional look at the realities of spec-driven development, or SDD. We're going to examine the tools, the highly predictable failures we're seeing, and the rigorous discipline that's now legally and operationally required in 2026. Here's our roadmap for today. We'll be looking at the 2026 SDD Toolbox, 4 silent failure modes, the context contamination trap, the RPI phase discipline, and finally the regulatory compliance mandate.
Let's dive right into Section 1, the 2026 SGD Toolbox.
To truly understand this recent market explosion, you really only need to grasp one foundational equation. Your AI agent is just a raw reasoning model combined with a harness. The model itself, your GPT or Claude, that's just the engine. The harness is everything around it. It's the instructions, the rule files, the sandboxes, and that harness is your true surface area for control. In fact, one team recently took a coding agent from outside the top 30 on Terminal Bench 2.0 straight into the top 5, literally just by changing the harness. Spec-driven tools act exactly as that harness infrastructure.
Now, we're seeing a few distinct philosophies driving the market right now. First, you've got integrated, spec-first tools like AWS's Cairo and GitHub's Spec-Kit, which rely on rigorous phase-based ideation. Then there's multi-agent orchestration, think BMAD method or HV core, which use file-based handoffs between different AI personas, like an architect talking to QA. And finally, you have low-ceremony tools like Ralph Loop, which put an agent in a simple loop with a completely empty context window for every single task. But here's the thing. Regardless of the philosophy, they all share one core shape. Requirements, then design, then tasks, all sitting on a persistent layer of rules.
Moving on to Section 2, 4 silent failure modes.
Because even with the best tools, real-world teams consistently hit roadblocks. First is a disguised waterfall process through over-speccing, basically writing a 50-page document before generating a single line of code. Then you have spec drift, where AI-generated code quietly deviates from the plan over time. That actually introduces 1.7 times more issues per pull request than human code. Then there's simple team adoption friction, where specs just get bypassed under deadline pressure. But the fourth, and easily the most dangerous, is AI hallucination, when the model makes assumptions far beyond the rules you've set.
This brings us to a really fascinating anchor concept for AI hallucination, the adjacent to correct bug. This is absolutely the modal failure of AI-generated code right now. It happens when the AI writes code that completely passes all your standard happy path tests, but silently ignores the spec's explicitly stated rejection behaviors. Experts are calling this vibe coding, and honestly, it is incredibly hard to spot manually.
Let's make this concrete with a real-world build from a platform called Skills Home. Requirement 4.1 explicitly stated that a system score must never be writable, and any request trying to change it must return an HTTP 400 error. Pretty straightforward, right? Well, the AI wrote an endpoint that silently accepted the read-only field, discarded it, and happily returned a successful HTTP 200 instead. It completely hid the flaw from manual testing. It wasn't until a property test generated 100 arbitrary request bodies that the team finally found this silently shipped undocumented behavior. The crucial point here is that this specific failure mode is highly predictable. Recent 2026 research shows that large language models still hallucinate package names in up to 22% of coding suggestions. And shockingly, 58% of those hallucinated package names repeat across multiple independent queries. The AI models are making the exact same mistakes over and over again. And that predictability, it turns adjacent to correct bugs into a massive attack surface. Bad actors are actively anticipating these repeating hallucinations and registering fake dependencies before real developers can catch the error. It's a practice known as slop squatting. To put that into perspective, in March 2026 alone, Georgia Tech researchers attributed 35 confirmed CVE vulnerabilities directly to AI coding tools doing exactly this. That takes us to Section 3, the context contamination trap. Even if you write the perfect spec, there's a hidden structural peril that destroys long agent sessions. Over the course of a long session, your perfectly crafted instructions end up competing with massive amounts of recent implementation context. You might start with 3,000 tokens of brilliant, strict instructions, but after just a few implementation cycles, those instructions are literally drowning in over 100,000 tokens of file contents, tool outputs, and newly generated code. We call this context rut.
Now, the model doesn't intentionally forget your spec. Instead, it structurally deprioritizes it due to architectural flaws in how AI attention mechanisms actually work. Specifically, things like rope positional encoding and softmax normalization naturally concentrate the AI's attention on the most recent tokens. Think of it like a spotlight that physically cannot widen enough to include older memories. Tests across 18 frontier models show accuracy dropping 30 to 50% as input length grows. This isn't a bug you can just prompt your way around. It is a hard architectural reality.
So how do we fix it? Section 4, the RPI phase discipline.
Microsoft's HVE core establishes a rigorous structural constraint to surgically eliminate this context rot, using the RPI workflow: research, plan, implement, and review. You assign each phase to a specialized agent with one narrow job. And here is the absolutely non-negotiable rule. You completely wipe the AI's conversation context between every single specialized phase. You don't summarize it, you clear it entirely. Microsoft is actually standardizing this right now, expanding HVE core to 68 artifacts across 10 different engineering disciplines.
By forcing the AI to write its outputs directly to a file on a disk, like a research.md or plan.md file, and then aggressively clearing the chat, you strip away the noise that competes with your critical engineering constraints. Always remember this: the file is the memory, the chat is disposable. This ensures that the AI relies strictly on verified, documented facts rather than suffering from degraded recency bias.
Finally, Section 5, the regulatory compliance mandate.
We have reached a critical turning point this year. As of August 2nd, 2026, the EU AI Act's high-risk obligations became legally enforceable. This means that deploying spec-driven systems in regulated environments has officially transitioned from just an engineering best practice into a strict, non-negotiable compliance posture. It is now the law. And the stakes here are immense. Failing to verify your AI output can now trigger severe regulatory fines. We're talking up to 15 million euros, or 3% of your global annual turnover. If your product touches a regulated category, your verification process is quite literally the only thing standing between you and a massive compliance violation. To navigate this new era safely, enterprises are actively adopting what's called constitutional SDD. This is an overarching, automated verification layer. It acts as a machine-readable constitution that encodes security constraints straight from the MITRE Top 25 vulnerability lists and applies strict regulatory obligations. It sits above your ordinary functional requirements, automatically intercepting those silent, adjacent-to-correct bugs before they ever have the chance to violate the law. As we wrap up this explainer, I want to leave you reflecting on this quote. Generation is solved. Verification, judgment, and direction are the new craft. The tools are absolutely here, but they require immense discipline and a fundamentally new workflow to manage context rot and regulatory law. So ask yourself, is your engineering team still treating AI merely as a generation tool, or have they truly mastered the new craft of verification?